How are you? So today in this session we are going to cover all those advanced part of the deep learning, and it's related to the natural language preprocessing, and it's indirectly we can call it as NLP. So here we are going to learn how NLP is evolved from all those previous its parts, and what will be its next feature and how now currently it's doing and working. So basically we will going to see bert model how NLP is evolving, and we will going to see on which part and area bert model is consist of. So for that I will going to use a pen, and just give me some time, I will write here. Okay, so we have in the previous video we have learned all about machine learning. Then we have also learned in the machine learning various types such as supervised, then semi supervised, and then unsupervised machine learning. In the supervised machine learning we have learned all those types such as linear model, then logistic, then random forest, then XGBoost, gradient boost, and so many. Okay, and in unsupervised we have also learned the k-means clustering, then hierarchical, okay, then db scan, it's also important, and so many. And in semi supervised machine learning it's contain the combination of both. Okay, so after the machine learning there is advanced level comes, and it's the deep learning. And deep learning consists of various types such as artificial neural network, it's called artificial neural network, and short form is ANN, and another one was convolutional neural network, CNN, I will write here. So ANN consists of many layers such as, but most important were input, then another one was middle, and final layer important was the output layer. Okay, so we have also discussed about how input layer consists of the number of features equal to the number of input neurons. Then we have seen how middle layers consist of how to give the dimension, how middle layers what it contains, various types of activation functions, and how those neurons get activated, dead neuron, and all those we have seen concepts. Also we have seen epoch, and in the epoch we have seen the feed forward mechanism, back forward mechanism. Okay, and we have seen various activation functions such as that neuron is like that type, and it's divided into the hub part. So first here we add the weight and biases, and here another part one is the activation type part. So it consists of the various types of activation functions. So the name of activation functions for linear, indirectly linear were ReLU, leaky ReLU, then eReLU. Okay, so release rectifier linear unit, then ELU is the exponential linear unit, means it's the best and advanced, because we have seen also some issue in the ReLU that it has a issue of uh, that exploding gradient issue, and when its curve comes before the zero or on the left side, then it will going to give the zero value, or indirectly we can consider it as a dead neuron. Also we have seen some activation functions related to the classification, and those functions are sigmoid if its binary classification 0 1, but the derivative of sigmoid function only lies between its value 0 to 0.25. So it's create the issue of vanishing gradient. Please be prepared very well here, because every interview will going to ask you question on that. Then another one was the 10H, it's the improvement in the sigmoid, but still it has an issue, and its range lies between -1 to 1. We have seen then Softmax, it's the best one, and now advanced models such as BERT, then GPU, then lstm, all those uses indirectly that Softmax. So it's a multi-classification. Okay, so we have seen how ANN work, and finally based on the output layer we get the problem as a multi-classification type, binary classification type, or any other. Then another part is advanced part is CNN, or we can call it as a convolutional neural network. Okay, so mostly it is useful to capture the image, and from the image or from their text based image it will going to capture most important features, and based on the features it will going to create the various pooling and padding convolutional layer, and lastly it will going to give one layer. So we will going to see how it works. Suppose if it's an image of dog or cat, then there is a one layer is, and it's called a convolutional layer. So in the convolutional layer it will going to identify various features of the that dog, such as ear, nose, then hair, or how its shape, color, and based on that it will going to create the various matrix in the number format. Then after that there is a concept of padding, no, not pooling. Remember, convolutional pooling is the concept. And in the pooling, what we do, we only reduce that dimension towards the lower one matrix, means we are converting higher dimensional to the lower dimensional matrix, and at the last one we are going to convert only it into the single dimension in the array format, and it will going to become the input of the above our networks, that it will going to consider as input layer of the ANN. And once again we are going to apply all those algorithms. So after pulling, there is a padding concept. Through the padding we give the kernel dimension, kernel matrix, and through that we select the various features. So here are also dropout layer. You may get to know dropout layer, it is used to reduce the complexity of the problem and to get the maximum more efficiency and to solve the problem within the time. So it is the CNN to extract the most important features, or for the image classification it is used. But friends, now in the recent world, whatever you have data preprocessed, the data you have got through the images or the number or the numeric, it's only 10%, and remaining 90% data is the unstructured data. It's the unstructured data. Now whatever most of the industry is doing work, it's based on the structured data. Structured data means it consists of the ranking, number, or tables. It can be classified, it can be arranged, it can be ranked. But here in the unstructured data, it's in the format of editor, newsletter, emails, text, books, summaries. So many companies or so many peoples are every day, there is a billion or million types of data is generated through the unstructured data. So 90% domain is still untouched by the data scientist, and for that purpose NLP is evolved, and it's the natural language preprocessing, and it's based on totally work on the unstructured data, and it will going to get the meaningful or insightful data from that unstructured data. So it's a very interesting, and it's very easy, and you will get to know how it can be become useful in the future. So NLP is the natural language processing, and it consists of various steps, such as, suppose you have given one paragraph that I have written some, please subscribe my channel and comment any suggestion. If I write this one, suppose this is one sentence or paragraph, and suppose in between there are so many sentences. So for that NLP, we have, for that unstructured data, we have need to use first step. For that we have need to use various libraries such as NLTK, natural language toolkit, and through that toolkit we import various functions such as sentence tokenization, then word tokenization, then punctuation, then TF IDF, it's a vector, then count vectorization, then word to vector, it's a deep learning model. Okay, so basically you should must know all those things. So in the sentence tokenization, what we do, whatever the paragraph we have given, or if there is very large sentence, then we divide the large sentence into the sentence, one sentence. So it's called a sentence tokenization. After sentence tokenization, we do the word tokenization, means each word in the full sentence will be converted into the one word. And after words tokenization, we do the lemmatization, stemming and lemmatization. So it's very simple. Stemming and lemmatization, it here we nothing but we can reduce the length of the word, or we can restore the root meaning of the word. So if suppose there is a one word that it's consider any word like that, greater, then if you use that stemming or lemmatization, then it will going to give a root word such as great. But in the stemming, what happens, if suppose there are any words like best or like, still it will going to reduce that best word to the base. So it will going to give sometimes unnecessary words, but lemmatization will going to give you only best words, so it will going to give you accurate words. So lemmatization is most accurate. So after doing this, you need to use the to convert all those text into the numerical one, there is a various operations such as count vectorizer. I have told you and learned you all those. Then second one and better one than count vectorizer, TF, IDF, term frequency, inward document frequency. It's best one, but it has still issues such as semantic or cosine similarity. It will not going to give the right meaning to the adjacent words. So there is another one is word vector. So it's a best one, and based on the sentence it will going to give the assign the values to the each word, and according to that all words value will be given. But still here are so many issues in the that NLP. It's a very simple process, because suppose if I give a sentence, I like I like to dance on bank of river, and if I want to convert that sentence into the Hindi or any language, and if we do simple that process, then definitely here it will not going to work, because here we are just going to make a classification of problems, so it will not going to give the meaning sentences. So next part of NLP was to get the right sequence. It is the RNN. So RNN is the recurrent neural network. So here what will happen, best part is that it will going to remember the sequence. Very important part of recurrent neural network is the sequence. So it will going to remember the sequence of word. After I like words come, after like two words come, after two that dance word will become, and so according to that it will going to give the label and number and vectors to the word. But and based on the feed forward mechanism and backward mechanism, it will going to give the vectors to the word, and we will get the accurate result. But here are some limitations of it, that it only uses feed forward and backward propagation, and if the length of the sentence is very high, then automatically it will going to fail if length is large, because it has a memory loss issue, and it only uses feed forward and backward, so it has a not accuracy. So then next version of it came, and it is the LSTM, recent one. So long form of LSTM is large short term memory. So in LSTM what happens, it has a very large and for short time high memory, so it will going to give you a accurate data for the large and long text paragraphs. But still there is an issue if you give a sentence like I like to dance on the bank of river, and another sentence was I withdraw 1000 from my bank account. So in the LSTM it will going to make a similar syntax or similar word vectors to the bank, and it will not going to classify bank of the river and bank of account. So LSTM will be here going to fail here. So next version of LSTM came is the bidirectional LSTM to get the accurate meaning of the words. But in the bidirectional LSTM it will going to get the meaning of word in the right direction, also in the left direction. But still, if the bank word is far away from, if one bank word is present in the one paragraph and another bank context word is present in another paragraph, then here bidirectional LSTM also going to fail, because it will not going to take huge context. So based on that, then there is a advanced version, and it's called as a transformer. So it's very important, and every data scientist must know about that one, and in the future it has a very high scope. So transformer consists of encoder and decoder. So it's a very depth part, but I will try to teach you in the very simple and easy stone manner. So in the encoder, what it will do, suppose if you are given one sentence, my name is Lakhan, and I want to convert it into the Hindi, मेरा नाम लखन है. So remember here, Lakhan word in the English language at the last place, but in the Hindi it's from the last second. So there are very different languages where first word will come to the last and last one will come to the first. So that LSTM or RNN will not going to give the accurate meaning and position to the vectors. So through the transformer, through the encoders, we will get perfectly that positions. And I will tell you about encoder. So encoder consists of various layers. So first one was the input layer, then there is encoder which will going to split that sentence into the words, and according to word it will going to give the numbers. And so in the encoder there are various mechanisms and situations, such as first one is the position encoding. Means each word has given the one position number. My word is given 1, name is given 2, is given 3. After that, position encoding. After that, attention layer. So attention were made in the particular sentence from the how that word is relevant to the that sentence and to the nearest sentence one, and according to that word vector value will be given to the particular numbers. And after that, very important layer is the self attention. So in the self attention, it will going to do, encoder will going to do, it will going to check each and every word from given sentence to the other sentences of throughout the context of the given that whole paragraph, and according to that it will going to give the value to the particular word to translate the language. So that's the very speciality and uniqueness about the encoder, and that's why it's very smoothly and easily will going to convert that your given data into the another language without affecting its meaning. And I will tell you about the decoder. So decoder is also last part. So whatever we have got the all the vector values from the encoder, decoder will going to convert those value into the other language, and it will going to use again encoder, and in the decoder, encoder will going to arrange all those other language words into the based on the numbers of that decoder inputs, it will going to arrange the value of other languages words, and it will going to form the sentence. So we'll get the output of the other sentence. So that is the magic of transformation, and it has a very huge mathematical institutions such as word key vector, then value vector, then it consists of softmax function, then it has a multi-layer embedding layers, and based on that it will going to create the output. So BERT is the advanced model which uses the transformer, and in that transformer BERT only uses the encoder. Remember here BERT not uses the decoder, and based on the encoder BERT will giving various types of results, and many search engines such as Google, it's a giant big company and search engine, then Facebook, Amazon, Netflix, all those for query search or text to speech or chatbots, all those using the BERT now. And whatever question you have asked, BERT will going to convert that question into the any language. If you want to translate your text, if you want to convert PDF into the image or image into the text, then here BERT is used to translate all those, and BERT will going to give you each word a specific value vectors, and based on that it will going to remember which word in sentence where you have need to keep, and based on that now Google is or so many artificial companies are now able to create the moral stories based on BERT. So they can get the summary of the book, they can easily translate to any other language, any language translation, and so many uses given by the BERT. So long form of BERT is bidirectional encoder representation of transformer. So please remember it's very, and it's BERT just launched in the 2020. It's a recent one, and there are various versions of BERT such as BERT small, which contains the small train data, BERT large, where whole Wikipedia data in more than 220 million words were trained on the BERT model, BERT large. Okay, and other version is also distill BERT. So in the distill BERT, instead of taking all the specification from the BERT based on your business problem and cases, you can add some features and you can use. So it's a faster with whatever specific features required. So if you want to specific features from the birds, instead of taking it to take it takes a long time, but based on your condition you can use that distill birds. So that's about the BERT, and you get to know how BERT is working and the transformer principle behind it. And after BERT there is now advanced is the SPACY. So SPACY is the advanced natural language preprocessing tools, and it consists of the BERT model. Also it consists of the token to vector. We have seen word to vector. Token to vector is also a system, and through the BERT and SPACY we can do what we can do in the NLP. So see, we can make a summary, we can easily make a translation of language for the name entity recognition, for the NER, named entity recognition. It's very useful. Suppose if there is a financial domain and you have got a very huge paragraph, or you are getting lots of emails and customer complaints and everything, and you want to segregate all those data into the finance, then loan, then debt, Then based on all those conditions you can give the named entity for this. For the medical purpose also you can create the named entity, and based on that you can give all those names for this specific domain. So there is a bert model and it is already pre-trained model, and it can give automatically. If you pass any sentence into that, then it automatically give all those values into the model. So remaining part of the model we can see in the next session. If you have any doubt, comment, or any future video, please ask me and suggest me. Thank you. Bye bye. Share, like, subscribe channel.